This is question number 7. A piston having a cross-sectional area of 0.07 meters square is located in a cylinder containing water as shown in figure 7. An open U-tube manometer is connected to the cylinder as shown. For H1 equal to 60 millimeters and H equal to 100 millimeter, what is the value of applied force P acting on the piston? The weight of the piston is negligible. So here, what you need to understand is, for this condition, mean for H1 equal to 60 and H equal to 100 millimeters, it will create a pressure at this point. So, and then this pressure will act on the surface and then it will create force. So in equilibrium, the force that push the piston here will be equal to the force that push the piston on the opposite direction. So we need to calculate the value of P here. So and then we could start like this. We know that the relation between force and pressure is F is equal to PA. So in this situation, we could write as P1 here. So and then according to this line, from the idea of Pascal paradox, we could say that P5 is equal to P4, it is equal to P3, and then it is equal to P2. So and then we could calculate the P5 here by calculating the height of this liquid. So and then we could write it is equal to rho GH plus the atmospheric pressure that acts on the surface. Okay. Okay, so and then this is the equation for P5. So and then for so this is the equation for P5. So for P2, we could calculate as this one, because this point at number 2 here is equal of rho GH1 plus the pressure at point 1 here. So and then we could from the idea of this one, so it is equal to P5 here. So it is equal to rho G 0.1, and then it's equal to P2, and then it is equal to rho G 0.06 plus P1. So according to this calculation, we could get the pressure at point number 1 is 12,753 Pascal. So and then we multiply it with the cross-sectional area, we could get that the force that push the piston is equal to 892.7 newtons.